Dear student, 2D transformation is an important properties in computer graphics. We need 2D transformation in computer graphics because for proper visualization of an object into a screen, we need transformation. So transformation means is defined by the changes of an object, changes like shape, size, orientation, or position. The implementation such changes is called transformation. There are different types of transformation are occur: rotation, scaling, reflection, translation, sharing. Before start this operation, we need some basic knowledge about in mathematics, like how to represent a matrix format how to represent a linear equation into a matrix format, matrix multiplication, and we have to know the basic concept about the transpose of a matrix, and also we have to know the pre-knowledge of coordinate geometry is very important. Now, while representing a linear equation in a matrix format, there are two ways to represent in a matrix format. First one is row measure order, and second one is column measure order. In row measure order, column measure order. In row measure order, all the points of an coordinate geometry it represent in row wise. For example, if there are 3 points exist, P1, P2 and P3, so I have to represent in row measure order P1, then row wise P2, row wise P3. In column measure order representation, if a point P, the coordinate is xy, then it can be represent xy. Is column wise. All the points are represent in column wise. So for example, P1, P2, P3, there are 3 points we represent in column measure order P1, second column P2, third column P3, in that way. Now I'll start the operation, discuss operation one by one. First, rotation, 2D rotation. So rotation is an important properties in computer graphics. Rotation means changes the object orientation or object coordinate along a circular path, either clockwise or anti-clockwise. So this operation, that is a rotation operation, can be performed in two ways: rotation about an origin and rotation about an arbitrary point or fixed point. So first I discuss rotation about an origin. Suppose, so rotation about origin. Rotation about an origin. Suppose a point placed on 2D plane, that is xy plane, location is P, x, y, coordinate, and also consider the distance from origin. Distance from origin is r. Distance is r. And also consider the angle between the points and x-axis is phi initially. Now I want to discuss If the point P rotate theta degree anticlockwise, then what is the new location of the point P? So if I rotate theta degree anticlockwise, so new location of the point P, definitely it will be P prime. New coordinate is x prime, y prime, and this is the theta. Now I know the relation between the Cartesian coordinate and polar coordinate, that is x equal to r cos phi or cos theta and y equal to r sin phi or sin theta. So here it will be distance is x and this distance is y and coordinate is xy. New coordinate, it is x prime and it is y prime. I can relate this equation in other way, that is, if a triangle is the x-axis, this distance is y, this is hypotenuse is r, opponent is y, and for this triangle I can write here the angle between the perpendicular and the adjacent axis is base is x. This is the adjacent, opponent and hypotenuse. Now this is angle is phi. Now cos phi equal to x by r, so x equal to r cos phi. Similarly, sin phi equal to y by r, so y equal to r sin phi. This is the way I can relate, both are same. Okay, now after rotate theta degree anticlockwise, new angle between x-axis and new coordinate, new location p prime is theta plus phi. So I can write new distance x prime or new coordinate x prime equal to r cos phi plus theta and y prime equal to r sin phi plus theta. Now if I derive this equation, that is r cos A cos B minus r sin A sin B. Similarly, derive this equation also, r sin A cos B plus r cos A sin B, that is A means phi, B means theta. So r cos phi cos theta, r sin phi sin theta, r sin phi cos theta, r cos phi sin theta. Now I replace the original value, r cos phi equal to x, r sin phi equal to y. So I will get we will get x cos theta minus y sin theta. We will get from this equation y cos theta plus x sin theta. Now this equation if I represent, so I can if I finally we get x prime equal to x cos theta minus y sin theta, and y prime equal to, if I rearrange this equation, x sin theta plus y cos theta. Now in the linear equation, if I represent in matrix format in column measure order, so new coordinate x prime y prime written as column wise equal to x prime equal to x into cos theta, y into sin theta. So coefficient of x is cos theta, coefficient of y is minus sin theta. Now y prime equal to x into sin theta plus y into theta. So coefficient of x is sin theta and cos theta. So if we rotate theta degree anti-clockwise, original coordinate. So this is for transformation matrix. This is the transformation matrix. For theta degree rotate theta degree anti-clockwise, that is t theta positive equal to this cos theta minus sin, cos theta minus sin theta, sin theta cos theta. So similarly, if I rotate anti-clockwise, so rotate anti-clockwise, so x prime will be r cos phi minus theta and y prime equal to r sin phi minus theta. So if I derive this both equation, we will get x prime equal to x cos theta, x prime equal to x cos theta plus y sin theta, and y prime equal to y cos theta minus x sin theta. So if I represent in matrix format, x prime y prime equal to cos theta sin theta, y coordinate, and y prime equal to x into minus sin theta. So minus sin theta, coefficient of x is minus sin theta and coefficient of y is cos theta, as we represent in column wise format. Next. Thank you.